we're going to explore combined events and the and rule. So now let's look at the probability of rolling a 6 when you roll a dice. Well, that's very simple because it's the probability of 1 in 6 because only 6 appears once. Now let's look at the probability of an even number. Well, we have the choice between 2, 4 and 6. So that gives us a probability of 3 in 6. And again then, the probability of an odd number is 1, 3 or 5. So that's going to be 3 in 6. And they both break down into 1/2. The general rule is that we say that the probability of an event E is the number of desirable outcomes over the number of total outcomes. So the total outcomes here is 15 because it's 5 red and 10 blue. And what we want is the probability of a blue. So what we say is that the probability is 10 in 15 and that breaks down into 2/3. Let's take this question for example. You're going to need to know the makeup of a deck of cards for this. But in a deck of cards, the probability of a jack is 4 because there's 4 jacks in a deck. And in our deck, there's 52. So let's write that as a probability. So the probability of a jack is 4 out of 52, or more specifically 1 in 13. Now let's look at the probability of finding a heart. Well, there's 13 hearts in a deck of cards because there's 13 hearts in the suit of hearts. So let's write that as a probability. So the probability of a heart is 13 out of 52, or more simply breaking down, it's 1 in 4. So let's have a look at this question. 2 fair die are thrown together and the scores are added together. And in part A, we're asked to draw the two-way table. So here it is done for us. This is the first dice and all of the outcomes that it has, and here's the second dice. So when they said the results are added together, basically if the first throw is a 1 and the second throw is a 1, then the outcome is 2. If the first throw is a 2 and the second throw is a 2, the outcome is 4, and so on. Okay, so you're adding the outcomes of the dice being thrown. Now, we're asked to find the various probabilities of these events occurring. So first of all is the probability of a 7, the probability that it's less than 5, the probability that it's greater than 5, the probability that it's even or divisible by 3, or even and divisible by 3. Well, first of all, we need to find out how many outcomes do we actually have. What is our total number of outcomes? Well, we know that our total number of outcomes is 6 times 6, which is 36. Now, there's 2 ways we can do this. We can do the multiplying, okay, basic principles of counting, or we can literally add all of these up. It's up to you whichever way you would prefer, but generally you use the combination rule. Now we recall that when we want the probability of an event happening, we put the number of desirable outcomes over the total number of outcomes. So for this question, our total number of outcomes is going to be 36. Well, first up we have part 1, and part 1 says that the probability of a 7. Well, the probability that it's 7 is equal to, well, if we highlight all the 7s, we've got 1, 2, 3, 4, 5, 6. So that means we have a 6 in 36 chance, and that breaks down into 1/6. And remember, we always give the probability in its simplest form. Now let's have a look at the probability that it is less than 5. So probability less than 5. Well, the probability of that is any number that's less than 5. Well, let's highlight the numbers that are less than 5. We've got 4, 2 3s and a 2. So that gives me 6 possible outcomes that are less than 5. So that means it's, again, 6 out of 36, which breaks down into 1/6. Now let's have a look that the probability is greater than 5. Well, very simply, if 6 out of the 36 outcomes are less than 5, that means that there's 30 outcomes that are 5 or greater. So it's 30 out of 36, which is going to leave me with 5/6. And that's our probability there. Now let's have a look at the probability of when it's even or divisible by 3, or when it's even and divisible by 3. So for part 4, highlight and try pick out all of the outcomes that are either even numbers or they're divisible by 3. So let's have a look at the ones that are even. So let's highlight all the even numbers. Well, we've got 2, 4, 6, 8, 10, and 12. And if we look at all of the ones, they're the even numbers, and then we highlight the ones that are divisible by 3. Well, divisible by 3 is 3. Then we've got 9. And we also have 12. So that leaves us with a total of 24 outcomes that are highlighted. So this leaves us with a 24 over 36, which very simply breaks down to 2/3. And now let's see if we can find any even and divisible by 3. Well, it's even and it's divisible by 3 means that it has to be both. It has to be an even number and it must divide by 3. So that actually narrows down our outcomes. So if we circle them instead, so if we want it to be even and divided by 3, so straight away we know it's going to be 6, because 6 is an even number and it has a factor of 3. And we also know that 12 is an even number and it has a factor of 3. So what that leaves us with then is a total of 6 outcomes. So for part 5, it must be even and divisible. So that only leaves us with 6 in 36. Which is 1/3. And if we look, 2/3 and 1/3 makes one full table. So we know that our outcomes are correct. Parts 4 and 5 of this question require a little bit of thinking. And we're going to look now into the and or rule. And what does that mean when we're talking about probability? See how you go with these questions now and complete them as a task. Now let's have a quick look at the and or rule. So a bag contains 15 marbles, 6 blue marbles and 9 yellow marbles. A player picks a marble at random from the bag. Its colour is noted and the marble is returned. So this is an example of an independent event. No matter how many times the trial happens, the number of outcomes doesn't reduce because the marble is put back into the bag. And the process is continued again. So we need to find the probability of getting 2 blue marbles, a blue marble and a yellow marble, a blue marble and a yellow marble in any order, at least 1 blue marble, and 2 marbles that are both the same colour. Now this might sound like an awful lot, but let's break it down and answer it together. First of all, we need to find out what exactly is the probability of getting a blue and what is the probability of getting a yellow. So see, can you figure that out there now? So here we have the probability of blue is a 6 in 15 chance, which breaks down to 2/5 or 0.4 as a decimal. And then we have the probability of yellow is 9 in 15, which is equal to 3/5, and it's equal to 0.6. Now, note that your 0.4, if you add it to 0.6, it's going to give you 1. So that's a key thing to remember with probability, that all your outcomes will have to add to 1. So this is the one experiment, and they have to add it to 1. Now, let's find the probability of 2 blue marbles. Well, we need a probability of 2 of them, so we'd write it like this. We would say, so part 1, the probability of blue and blue. Okay? And remember, and means multiply. So the probability of blue must be multiplied by the probability of blue again. So 0.4 multiplied by 0.4. and that's going to give you 0.16. Because remember, up here is the probability of a blue and a blue. So that means we multiply. Now let's look at the probability of a blue and then a yellow marble. Well, that means we've got the probability for part 2. We have to think of the probability of a blue followed by a yellow. Well, again, it's blue and yellow. So what we say here is it's 0.4 times 0.6, which will give us 0.24. Now let's have a look at the probability of a blue marble and a yellow marble, but it can be in any order. So it can be blue and yellow, or it can be blue or yellow and blue. So we're going to be looking at the probability. So this is for part 3. The probability of a blue followed by a yellow, or the probability of a yellow followed by a blue. Well, blue followed by a yellow, the probability of that is 0.4 times 0.6, because it's blue or yellow. And then you have to add that, because it's or, to the probability of a yellow, which is 0.6, and the probability of a blue, 0.4. And when you do that, you're basically saying what is 0.24 plus 0.24? Well, that quite simply gives you 0.48. So to explain this, here you're saying it's blue and yellow, or yellow and blue. So this is like saying blue and yellow. And remember, and means to multiply. And this is like the opposite, basically. What if we got yellow and then blue? And in that case, we need to multiply the two outcomes. For part 4, we're going to be looking at the probability that at least one blue marble, which means one or more blue marbles. Well, that means that we're looking at the probability of 2 blue marbles plus, because it's or, so it's plus the probability of maybe a blue and a yellow, because it's one or more blue marbles, or the probability of a yellow and a blue. Now we know the probability of a blue and a blue is 0.16. And from the previous question, we know that the probability of a blue and a yellow is 0.24. And again, from the previous question, the probability of a yellow and a blue is still 0.24. So when we add those all together, we get 0.64. And that's the probability of at least one blue marble. So each outcome has to have one blue marble, but like in the first one, you can have 2 blue marbles. Then if we look at part 5. Part 5 says that it wants the probability that 2 marbles that are both the same colour are picked. So you can have blue, blue, or you can have yellow, yellow. So what is the probability of 2 blues or the probability of 2 yellows? Well, we know that the probability of 2 blues, just like above, is 0.16. And the probability of 2 yellows is going to be 0.36, because it's going to be 0.6 times 0.6. So it's going to be plus 0.36. And how I got that was because 0.6 times 0.6. And when you add those together, you get that the probability of that both marbles are the same colour is 0.52. And that's that question fully answered. Now you need to be careful when you're answering these questions that you don't get too caught up on the terminology, but that you read it really carefully and see what exactly are they looking for the probability of. And we're going to practice one question on the and or rule. See how you go with this question and complete it as part of the tasks.